Alright guys, good afternoon. Welcome back for another video. Today we're going to continue on talking about mechanisms, and we're going to finish out the rest of the mechanisms. Now, most of these that you see you're going to be building tomorrow in class. We'll be taking turns building a few at a time, so you won't build all of them, but each of you will build at least one of these. This is called the worm and wheel. From the worm and wheel, these are things you need to take away from it. One is the angle. It's a 90-degree angle. Speed is decreased. Torque is increased. So you can look right here, you see this is the worm, and this part right here is the wheel. Gear ratio, we have 24:1. And what you do with this is, in order to calculate it, you turn this handle around, and every time you turn it around, you see how far this goes. By the time this goes around one time, you'll have turned this handle 24 times. Now, as we've talked about, that's very high torque. Flow of power is not reversible. If you grab the wheel and start to spin it, it's not going to turn the worm part. And you'll see this in class once we create it. Direction of travel is also not reversible. Where do you find a worm and wheel? So let's get a few examples. One, you'll mostly recognize this, is a guitar. In the guitar, when you turn the handle just a little bit of a turn, it will turn the pin that's holding the strings. Electric motors have them, winches have them, and we'll see how to build one in class, talk about it. A worm is used to reduce speed and increase torque. The motion is not reversible, so a gear cannot drive a worm, which means it's a great thing to use for a car jack, because once you jack the car up, it's not going to go back down until you start to spin it the other direction. Lead screw. This right here, we're looking at rotary, so it's going to spin around in a circle. The input is rotary, the output is linear. So this is a slide right here. It's going to slide back and forth as you twist this handle. Revolutions, 4.75 revolutions. So you talk about how many revolutions it takes to go from one side to the other. If you notice, there's no gear ratio here. And the flow of power is not reversible. And the force is increased. So we're increasing the force. Think of force. You say, well, what about torque? Because the last one we had torque on it. Well, this is force because as you're spinning one rotary, it's pushing force in a linear direction. Remember, force is linear. And direction of travel is reversible. So you can spin it one way, it'll go this direction. Spin it the other direction, it'll go back. Now, we see lead screws. Here's a scissor jack for a car. Sometimes you see them in vices. So what happens is, as you turn the screw right here, these two sides come together, lifting the car up. It allows you to lift a lot of weight at the same time. Rack and pinion. Remember this little emblem up here on the top right side? Well, you're going to build one of those. You're going to use a slide, and you're going to have a gear right here that turns. A couple things to know about it. This is the pinion. This is the rack right here. So, input is rotary, output linear. With a larger pinion gear, the rack will move a longer distance. So think of that. This is the pinion. So if you put a large gear on it, it's going to spin faster, greater distance. The flow of power is reversible. And this one, if you push on the rack side, then it will actually spin the pinion. Or if you spin the pinion, it will move the rack. Both. And direction of travel is also reversible. So you can spin it one direction or the other direction. It'll go left or right. Where do we find them? Well, we see them in a couple places. One is we talked about this is an ice cream scoop. So as you push one direction, it's going to move the ice cream scoop one way and then back the other way. So steering systems is a major one. We see a lot of rack and pinions in cars, automobiles, side-by-sides. We might even bring a few in to try them out. Universal joint. Universal joint is going to be 90 to 270 degrees. Right here, this shaft that goes through the middle. If the shaft is turning at one speed, the shaft on the other side is going to turn at the exact same speed, so it's constant. Ratio is 1:1, and the flow of power is reversible, and the input and the output is the same direction. So if you turn to the right or turn to the left, it will turn both sides. Here's a picture of the universal joint. You're going to need to just come into the classroom, move it around, play with it a little bit, and then see exactly how it works with your hands. Where do we find them? Okay, drive shaft on vehicles, power takeoffs, Universal joints are used to transmit rotary movements at an angle that is not 90 degrees. Okay. Chain drives. A lot of you have seen these on bicycles, motorcycles. Let's talk about the different parts. The angle. They are parallel. You know this. If you take one of these cogs and move it around or angle it, the chain is not going to drive on it. This one right here, this is the drive gear. The drive gear. This is the driven gear. So we know that the speed, if the drive gear is larger than the driven gear, the speed will increase. The torque will decrease. This one, the gear ratio is 18 to 30 or 3 to 5. Smaller drive gear. So let's say we switch it. So we put the drive on this side, and this is the driven. Then it just flips it. The speed is decreased, and the torque is increased. Shaft direction. This shaft right here and this shaft will both turn in the exact same direction. Motorcycles, bicycles. Okay. Advantages of chains. Transfer torque and speed over a long distance. Think about all the number of gears you'd have to have. Here's another advantage. The motorcycle, the rear gear, is able to go up and down with the shocks to absorb shock. And what that does is the chain allows it to move freely while still maintaining power on it. Belt drive. Now, we've noticed more bicycles being made and motorcycles being made with belts now. Part of that is a downside to a chain is if it breaks or if you get an item hooked into it or caught on it, it could be very dangerous. Right here we have the handle, so this is going to be our drive side. Over here we have the driven side. The shafts are parallel, the speed is constant, the torque is constant, and the ratio is 1 to 1. They're the same size. Okay. Speed increase, torque decrease if the larger drive pulley. So depending on the size here, just like all the other gears, even if you have a larger gear here, smaller gear here, that will increase speed, and flip it. If you have a smaller gear here and a large gear here, it will increase torque. Both of them are going to drive in the same direction, but then there's something a little interesting. Crossed belt. You can actually flip the belt over and they will go in opposite directions. We see this in cars, lawnmowers a lot of times. If you look right here, interesting thing about a belt and a pulley is if they're both connected this way, they both spin the same direction. If it is crossed over, then they will spin in opposite directions. And it can also change to 90 degrees. So you can have a drive gear here, but the driven gear is facing the other direction. So it's turning. They are quieter, less expensive, and less likely to injure you if you happen to get clothing caught in them. Crank and slider. Now we've all seen steam engines or steam trains. This is basically the same motion. Input is rotary right here. Output is reciprocating, sliding back and forth. Okay. Slide moves 2 inches. So it's only going to move 2 inches. There's no gear ratio here. It's not going to travel one way and then the other. Increased crank, so increases the distance of the slide. So the larger the crank, or crank handle, the longer the distance. That's what changes. Not the ratio, the distance. And the flow of power is not reversible. If you grab this slide and push it forward, it may move the crank just a little bit, but then it's going to stop. So it's not reversible. Where do we find them? Steam engines, pistons, inside of cars. We see them in a lot of places, a lot of machines that we use. This one, cam and follower. Look right here. This piece right here is the follower. This piece right here is the cam. As this turns, this is going to lift, and once it passes, it's going to fall down, and then it's going to be lifted up again, and then it's going to fall. You're going to build one of these in the classroom so you can use it and understand. Input, rotary. You're going to turn the handle. Output, reciprocating. This goes up and down. Follower moves up and down 1 time for every revolution of the crank. So we do not have a gear ratio here again. Flow of power, however, is not reversible. And the direction of travel is not reversible. If you spin this to the right, then it will go up and down. If you spin to the left, it will get stuck. If you grab this follower instead of the cam and start pushing it up and down, the device will go nowhere. So flow of power, not reversible. Direction of travel, not reversible. Alright, where do we find cam and followers? Same thing, in a car, these right here are tacket valves. And your tacket valves allow different amounts of gas and air mixtures and then gases to escape. This is a camshaft, and what it does is it goes up and down. In this little bar, as the shaft rotates, it will push it down and up, opening the hole that this is in. Ladies and gentlemen, this concludes your PowerPoint presentation, and I hope to see you tomorrow ready and eager to build and learn as much as possible. Thanks for watching, and please don't forget to go to Haiku, click Hand In, and leave a comment in Haiku over this video.